Hello everyone, I welcome you all in this C programming and data structures lecture. In this presentation, we will learn how to write a program to find prime factors of a given number and how to print all the prime factors of the given number in descending order. This is part 1 of this program, so without any further delay, let's get started. We are interested in writing a program to print all the prime factors of a given number, and that too in descending order using a stack. So we will use a stack to print all the elements, that is the prime factors of a given number, in descending order. Stack will actually help us in printing all the elements, all the prime factors in descending order. Okay. Before printing all the elements, we must have to find the prime factors of a given number. Isn't that so? For this purpose, we must know the prime factorization technique. I am assuming that you are not familiar about this technique. So first we will understand how to do the prime factorization of a given number. Let's try to understand the prime factorization technique. Prime factorization technique is very simple to understand. In order to understand this technique, we'll take an example. Let's say we have a number 12 and we want to find the prime factors of this number. Now my question is, what are the prime factors of 12? In order to find the prime factors, we will use this traditional technique called prime factorization. Here we have to draw these lines and here we have to place this value 12. Now, starting from 2, we will check whether 12 is divisible by 2 or not. Now you might ask me this question, why we are starting from 2? Why we are trying to divide 12 by 2? We know that 2 is the least prime number possible. This is the value you can assume, right? Let's try to divide this number by 2. If 2 divides this number completely, then obviously 2 is the prime factor of this number. Isn't that so? 2 is a prime number, and if it completely divides this number, then this means this is a prime factor of this number. Therefore, we will check whether 12 is divisible by 2 or not. We will write 2 over here and we will try to divide 12 by 2. If 12 is divisible by 2, then 2 is one of the prime factors of 12, right? Obviously 2 is a prime number. If it completely divides 12, then it becomes the prime factor of 12. If not, then we will choose another number. Okay. Here we are trying to divide 12 by 2. We know that 2 completely divides 12, right? And it will give this quotient, that is 6. Because 2 6 is 12. 2 multiplied by 6 is 12. So we can write 12 as 2 into 6. 2 is a prime factor of 12, right? After this, we can see this that 6 is actually a composite number. Therefore, we will try to divide 6 by 2. If divisible, then continue in the same way, else we will choose some other number. Okay? 6 is a composite number. If we try to represent 12 as 2 into 6, then 2 is a prime factor, but 6 is not a prime factor of 12. Isn't that so? 6 is a composite number. Obviously, 6 divides 12, but 6 is a composite number. We can further divide this. Please remember that we are interested in finding all the prime factors of 12. Hence, we cannot keep this value as a factor of 12 because 6 is not a prime number, right? We can further divide this. 6 is actually divisible by 2, right? Let's put 2 over here. And we know that 2 3s are 6. Therefore, we can place 3 over here, right? Now you can stop at 3 because 3 is a prime number. So eventually we can write 12 as 2 into 2 into 3. 3 2s are 6 and 6 2s are 12, right? These are all prime numbers and we can say that these are the prime factors of 12. Isn't that so? So prime factors of 12 are 2, 2 and 3. We are interested in writing all prime factors in descending order, aren't we? Therefore, we must write 3 first and then 2 and then 2. These are all the prime factors of 12 and they are written in descending order. Fine. Up to now we have got the idea how to do prime factorization. Now let's take one more example. In this example, we will see how we will use the stack for printing all the elements in descending order on the screen. Let's again look into the prime factorization technique. This time we will take some other example. Let's say we have a number 450. What are the prime factors of 450? In order to write the prime factors of 450, we will use prime factorization technique. Here, we will first try to divide 450 by 2. We know that 450 is completely divisible by 2, isn't that so? and 2 multiplied by 225 gives 450. This is the quotient, right? So we can say that 2 is one such prime factor, right? After this, the next step is to divide this number by 2. But wait, we know that 2 is one such prime factor, isn't that so? We know that 2 is the prime factor of 450. We can actually push this element onto stack, isn't that so? Actually, we will always get the least prime factor first, and you will see this that we will get the greatest prime factor at the end. Okay? We can actually push this element onto stack, and after pushing all the prime factors onto stack, we can pop them out of stack for the purpose of printing. Now we will push this element onto stack. For this we will call push function, and here to this push function we will pass this value 2. Let us assume this is our stack and we want this element to be pushed inside stack. After pushing, this is how it looks like, right? Now let's try to divide this number by 2. We know that 225 is not divisible by 2. Hence we will select a higher number, right? Let's take 3. 3 is also a prime number, right? Let's try to divide 225 by 3. 3 divides 225. 3 into 75 is 225, right? And now it is clear that we can push this element onto stack because 3 is one such prime factor, right? So let's try to push this element onto stack. And this is how our stack looks like. After this, let's try to divide 75 by 3. 75 is divisible by 3, isn't that so? So here we will put 3 and here we will put 25 because 3 into 25 is 75. Now this time we will push this element onto stack. Let's push this element. After this, let's try to divide 25 by 3. We know that 25 is not divisible by 3, hence we will choose a higher number. Let's take 5. 5 is also a prime number. We cannot take 4, remember that. 4 is a composite number, right? But 5 is not a composite number. 5 is a prime number. 5 actually divides 25, isn't that so? 5 5s are 25. Therefore, we can push this element onto stack. Why is that true? Because 5 is one such prime factor of 450. After this, we have this value 5. And we know that 5 is a prime number. Therefore, we can stop at this point and we have to push this element onto stack. So these are all the prime factors so obtained. 5, 5, 3, 3, 2. You can see the highest value is at the topmost position and the lowest value is at the bottommost position. After popping the elements out of stack, we would be able to print them on the screen. And obviously the highest value will get printed first and the lowest value will get printed last. Isn't that so? Now we will pop all the elements one by one and print them on the screen. So the result so obtained looks like this. 5, 5, 3, 3, 2. Right? These are all the prime factors of this number 450. Isn't that so? So this is the logic behind writing prime factors of a number in descending order. We will use stack for the purpose of printing all the elements in descending order. You can see every time we will select the higher prime number. That is why we will always get the least number at the bottommost place and the highest number at the topmost place, right? Initially we had selected this number 2, then after this 3, then 5, and finally we have obtained 5. All these elements are pushed one by one onto stack, and you can see that 5 is the last inserted element over here. If we try to pop elements one by one, then the topmost element will get printed first, then this element, then this element, then this element, and so on. In this way, we'd be able to print all the elements, that is all the prime factors of 450 in descending order. This is how we are maintaining the descending order of prime factors. Fine. Okay friends, this is it for now. In the next presentation, we will see the complete program to print all the prime factors of a given number in descending order.